Hello, welcome. Today we're going to be looking at lesson 6.5 and beginning to look at writing out proofs for similarity. So we want to kind of analyze what postulates and theorems we can use in those proofs, and then make sure that we can provide that evidence when we write the proof up. We will be using our note sheets attached to this lesson for lesson 6.5, or that's what it should be labeled at the top. Let me go ahead and share that so you can see what that looks like. I'll make this a little bigger. All right, so today we are going to be applying the side-side-side similarity and side-angle-side similarity theorems to prove that our triangles are similar. So we're going to look at exactly what you need to be showing as evidence in each one of these cases. So if we were using side-side-side similarity, we are going to want to show that all three sides are proportional to the triangles to make them similar. If you have three equal scale factors, you have proportionality. If they are proportional, they're going to be similar. So what we want to do when we match these up is make sure that we're looking at these scale factors and lining them up in order. So I would want to start with the smallest side of my first triangle, which is 3. And then I look to see what that corresponds to on the second triangle. So then always match that up with the smallest triangle over here, which is 6. We should see that that's going to reduce to 1/2. Okay, so 1/2 is going to be that scale factor. But let's go ahead and then take that middle length on this triangle. So my next smallest side would be 4, which would have to correspond to this one at 8. And I can see that would also reduce to 1/2. And then my largest side on the first triangle is 5, which corresponds to the largest side over here, which is 10. All three scale factors have to reduce to the same value. That scale factor in this case is 1/2. Okay, if you have the same scale factor with all three, then we can say that the triangles are similar. And remember, when we're saying they're similar, we're saying that they are proportional. Okay, so then if I were to look at this second option, again, the smallest side length on that first one was 3. The smallest side over here is 9. So now if I take a look at this, 3/9 is going to reduce to 1/3. So I need all of my scale factors to be able to reduce to 1/3. So let's look at that next smallest side, which is 4. That would compare to the next smallest one over here, which is 12. And 4/12 does reduce to 1/3. So far so good. But we have to check all three. So now we look at the largest side over here, which was 5, with the largest side over here, which is 16. Okay, here's the issue in this case. Will 5/16 reduce to 1/3? We should say no. It's close, right? That should have been a 15 if I wanted these to be proportional, okay? But it's not. So I do not have a scale factor here that is the same with all three sets of sides. So the triangles are not similar in this case, okay? But you do need to be testing all three of those. You can kind of tell by that scale factor, right? So 3 times 3 took us to 9. 4 times 3 took us to 12. So 5 times 3 should take us to 15, okay? But it does not. in that case. So I would be able to prove that these triangles are similar, but these triangles are not. All right, looking at our second theorem, we're now going to be using our side angle side similarity. And if you remember these types of theorems with congruence last semester, you know that you have to have these values in that order also as you move your way around your triangle. So just kind of keep that in mind when you're looking at your figures. So if we're using side angle side, we will need one pair of congruent angles, because angles have to be congruent to keep the same shape. And you can see we need one because we have one pair of angles in that statement. And then we need two pairs of proportional sides. And you can see you have to have two sets of sides there. Sides are proportional. So keep in mind when we're saying that they're proportional, they have to have the same scale factor. Okay, same thing up here. When they were proportional, we need the same scale factor. Okay, anytime you state that, that has to be true. So if I were to look at this picture and just kind of mark what I know by looking at that and aligning my corresponding sides, I should see first here at vertex B, I have vertical angles on that diagram. So those angles would be equal to each other. So my vertical angles are congruent. So I have one set of congruent angles. And if I look at my scale factors now, the smaller side here of 9 is going to correspond with the smaller side over here of 18. Okay, always make sure you're matching up the smaller side with the smaller segment on the other one because you're unsure if that's a rotation or reflection there. So match up the smallest sides. And then the next value there, 15, which is that larger value, has to match up with the larger one here. What we want to see is, will these fractions reduce to the same value? Well, I should see that 9/18 reduces to a scale factor of 1/2, and 15/30 also reduces to a scale factor of 1/2. Okay, so you have an equal scale factor there, making those sides proportional. Okay, so we say the vertical angles are congruent, and the scale factor of 1/2, okay, creates proportional sides. Okay, so if we just look at this little chart and kind of analyze these two theorems here, what I should be able to do is state the similarities between these two and the differences. Okay, so similarities, okay, we had to have, okay, two sets of proportional sides, okay, in each one of these cases, right? You had to have at least two here, and you had to have at least two sets of sides over here, okay? And then differences is that we had to have an included angle with SAS similarity. There was no angle needed, okay, in that first case because we just had proportional sides that we were analyzing. Okay, so here, included angle. Now, I want to go back and just kind of talk about that definition for a second because that was something we covered last semester. included angle means it needs to be in between those two sides. So as I work my way around the triangle, I should see I have a side, an angle, and then a side. They're in that order. Or I can see that those two sides meet at the included angle, or that angle between it. It has to be the angle between those sides to work for this case. Okay, so just be careful with that. All right, so if we continue on to kind of working with a few examples in this situation. Okay, we want to know, again, are the triangles similar? And if so, what postulate or theorem would we be using? Well, what I should notice in number 1 is that I have side lengths marked on here. So I should be testing my side similarity. So if I want to do that, I want to look at the scale factors and match those up. Well, 16 is the smallest side on this triangle, so it will have to match up with the 12 over here. And then I would have 20 that would have to match up with 15. And then the largest side of 32 would have to match up with the largest side of 24 in that second triangle. Okay, what we want to do is reduce these fractions now to see if those scale factors are all the same. So if you have 16 and 12, we should see that those both reduce or divide by 4. So I can reduce these to 4/3. 20 and 15 would both divide by 5. So 20 divided by 5 is 4. 15 divided by 5 is 3. And then here, 32 and 24, these both divide by 8. So 32 divided by 8 is 4. And 24 divided by 8 is 3. So I did get a scale factor of 4/3 in each case. Okay, so I would say yes, these triangles are similar. And we used side similarity, because I listed that 3 sets of sides were proportional because they had the same scale factor. In number 2, though, I would test this using side angle side because I have values in that order as I move around my triangle. A side, an angle, and then a side. So what we want to do is look at those scale factors first. The smaller leg on this right triangle is 24, which would correspond to the smaller leg over here of 16. And we want to see if that has the same scale factor with the longer leg. So I've got a longer leg of 28. Over here, a longer leg of 21. So what we want to do now in this case, again, is reduce these to see if we have the same scale factor between them. So 24 and 16 both divide by 4 for sure, and that would give me 6/4, which reduces again to 3/2. Okay, so I can get that to reduce down to 3/2. Or if you saw those divided by 8, okay, right away you could get to 3/2. Now 28 and 21 both divide by 7. So 28 divided by 7 would be 4. And 21 divided by 7 would be 3. So in this case, I get a scale factor of 4/3. Well, 3/2 and 4/3 are not the same scale factor. Those are not equal. So then, no, these triangles are not going to be similar. Okay, in part B, we want to determine whether 2 triangles are similar. If they are similar, write a similarity statement now and find the scale factor of triangle B to A. Okay, so I'll kind of take this in parts here as we work our way through. So in the first problem here, we're comparing triangle A to B. again, what I have are the lengths of the three sides. So I want to test this out. Now be careful when you're writing these scale factors. Again, the smallest side on triangle A is 12. That would correspond to the smallest triangle side of the triangle on triangle B, which is 9. So I'm going to write my scale factor that way, 12 to 9. So you'll see this is kind of a rotation here, okay, when you're setting that up or looking for your corresponding part. So then on triangle A, the second shortest side was 16, which will then match up with 12 on triangle B. And then the longest side on A was 20, which corresponds with the longest side on triangle B, which is 15. Now again, I want to reduce these fractions. So I should notice these both divide by 3. So that would give me a scale factor of 4/3. If I use 16/12, again, these divide by 4 now. So that would become 4/3. And then 20/15, those divide by 5. So again, 4/3. So same scale factor each time. So if we ask, are they similar? We would say yes. And if they're similar, we should now be able to write a similarity statement. Again, when you write your similarity statement, you want to match up corresponding angles. So we're going to say that triangle here, let's see, TRE. Let's see if I use that. That's going to be similar to. Now again, we rotated or turned this, okay, when we looked at the second. So T really rotates to R. Here, R would rotate to U. Okay, and then E would stay at E. Okay, to set up that similarity statement, but you want congruent angles to match up with each other. Sometimes it's easier if you actually mark the angles in there, right? We had right angles, okay, in both of those locations. Okay, then T rotated to R, and then at R, that rotated to U. Okay, it makes it a little bit easier to see in your similarity statement if you're writing it out. Now, here's how they want the scale factor written here at the end. So K equals, for my scale factor, I use that variable K. I want to compare a side length of triangle B to triangle A. So I want to put B in my numerator. So on triangle B, let's say I could use any of those corresponding sides, but why not the smallest? I had a side of 9 compared to triangle A of 12. So we would say scale factor here of 3/4. Again, if I look at that, then I can see scale factor is less than 1. So that should tell me that triangle B is smaller than triangle A. Okay, and you can see that from your picture. Okay, and number 2, at point Q, we should recognize our vertical angles. So I do have one set of congruent angles. So I should be testing this by side, angle, side. So what I want to see now, are these sides proportional? Do they have the same scale factor? So what I'm going to do, okay, is set that up. The smallest side over here was 21, which matches up with the smallest side over here at 14. Okay, then also the largest side of this triangle was 27, which matches up with the larger side over here at 18. To test those scale factors, see if they reduce to the same value. So again, these divide by 7, so we should get 3/2. These divide by 9, and we get 3/2 are the same scale factor. So yes, these are also going to be similar. I'm going to write my statement as PQT in that first one. then P would match up with angle S on my other triangle. Q with Q, there's the vertical angles, and then T rotates to R. Okay, and then my scale factor of triangle B to A. So I'm going to put B in my numerator. So I'm going to use the smallest side again of 21 to A, which was 14. And then that reduces to 3/2. So that should tell me, again, this is larger than 1. So triangle B should be bigger than triangle A. All right, so this is the first part of our note that I'm going to put in today for lesson 6.5. So this is going to end video 1.